Hey Matrix, welcome to today's video. This is part 1 of the series where we'll be going through the November 2020 past paper for chemistry. Today we'll be looking at question 2. If you don't have the paper, please pause the video now. There's a link in the description below where you can go and download the paper. Once you have the paper, you can then continue watching the video. Okay, before we get started with question 2, I just want to show you a 3D representation of some of the molecules. For instance, this is a carbon atom, so we can see that it can make 4 bonds, so there's 4 spikes on it. Okay, if we look at this one over here, 2 carbon atoms with a single bond between it, indicating it's our alkanes, and each one of these tags indicates another bond that the carbon can make. Okay. Then if we look over here, there's a double bond between the 2 carbons. Each carbon can still make 2 bonds. So this will be our alkenes. And finally, if we look at this one, there's a triple bond between the carbons. So this will be our alkynes. Okay, and each carbon can still make a single bond with something else. Okay, now with organic chemistry, if you're struggling with the question, you need to practice your theory more. Okay. The second thing is when you start the question, draw the structures that aren't given to you. For instance, if we look at B, we don't have its structure. D, we don't have the structure. And E, we don't have the structure. So I'm going to draw B quickly. So B's got 3 carbons. 1, 2, 3. Okay, but it's got 8 hydrogens. So 1, 2, 3, 4, 5, 6, 7. Okay, now, yes, I can put the 8th one here, but I need to include an oxygen. So we know that this is forming an alcohol. Okay, if we look at the next one, pentan 2, 1. Okay, the 1 over here on the end should indicate to you that it's a ketone. So pent means 5, so we're going to have 5 carbons. 1, 2, 3, 4, 5. Okay, and after the second carbon, there is a double bond oxygen. So you can do it on either side. I'll go this side. Okay. And lastly, if we look at this one, at the end here, the ane should indicate that we're dealing with a triple bond after the second carbon. Pent says that there's 5 carbons again. So 1, 2, 3, 4, 5. After the second carbon, there's a triple bond. So there's your triple bond. And then on the 4th carbon, we have a methyl group. Okay, now let's get started with the question. So question 2.1 says, for compound D, write down the homologous series to which it belongs. Okay, so definition of homologous series, it's molecules with the same functional groups and general formulas. Okay, so we're dealing with D, looking at it drawn out, we can see its homologous series is a ketone. Okay, so I've drawn it over here. We can see it's got a double bond oxygen to a carbon between 2 other carbons. So this gives us a ketone. Okay, looking at 2.1.2, it says the Iupac name for the functional isomer of D. Okay, now definition of functional isomer is molecules with the same molecular formula but belong to a different functional group. Okay, so let's have a look at the bottom. Originally I had this one over here. So my oxygen's on the second carbon. If I move the oxygen up to the middle carbon, I still have a ketone. Okay. If I move it to the end, I still have a ketone. So these are not changing its functional group. Okay. So the only way we can change the functional group is if we move the oxygen to either one of the end carbons. So I'm going to put it over here, double bond oxygen, which means this here will take 3 hydrogens. Okay, 1, 2, 3, this one needs another hydrogen. Okay, now by doing that, we've gone from a ketone to an aldehyde. Okay, remember, double bond oxygen on the end means it's an aldehyde. Okay. Let me just get the spelling. There we go. Okay, so we know that there's 1, 2, 3, 4, 5 carbons, so it's pent. Okay, and then the suffix for aldehyde is then given by anal. Okay, so we're dealing with pentanal. How did I come up with that? That's with your Iupac rules. So the first thing is you find the homologous series, which we found. It's an aldehyde. Okay, then we find the longest carbon chain, which we did over here. Okay, the next thing we look at is side chains. This one doesn't have any side chains. Then we look if there's any halogens attached. There's no halogens attached, so therefore we can write down our Iupac name. Okay, looking at 2.2, we're looking at the Iupac name for compound A. Okay, so I've drawn compound A up top here. Okay, please note that there's two methyl groups attached, plus there's a bromine attached as well. So running through our list for Iupac naming, we're looking for the homologous series, so we can see it's all single bonds, so we're dealing with an alkane. Next we look for the longest carbon chain. Okay, so I'm going to choose this one just for simplicity as my longest carbon chain. Okay, next we check side chains. Oh, with the longest chain there's 1, 2, 3, 4, 5, 6. Okay, then side chains, there's two methyl groups over here. Okay, and then lastly we're going to check for any halogens, and there's one attached over there. Okay, so we're going to name it first. Okay, but please take note, when you're doing the naming, we want the side chains to have the lowest number. So therefore I'm going to start counting from the left. Okay, which means my bromine is going to fall on the 5th carbon. So it will be 5 bromo. Okay, then 2 and 3 methyl. Okay, then there's 1, 2, 3, 4, 5, 6 carbons, so it's hex, and it's all single bond, so it's hexane. Okay, and that's how we go about finding the Iupac name. Hold up, do I even chemistry? Okay, my mistake here. If you've managed to spot it, well done. Okay, remember there's two methyl groups, so there should be a di in front here. Okay, so it should be dimethyl. So your final answer should be 5 bromo. Okay, 2, 3 dimethyl, because there's two of them, and then hexane. Okay, back to the video. Now for 2.2.2, it asks us the structural formula for compound E. Okay, so the minute you see structural formula, you should think of drawing. Okay, so let's have a look here. The ane at the end there indicates it's a triple bond. Okay, the 2 indicates it's after the 2nd carbon. Okay, then pent over here means there's 5 carbons, so 5 times carbons. Methyl indicates there's a methyl side chain. Okay, so CH3, and the 4 indicates that it sits on the 4th carbon. Okay, so let's draw this out. So we know that there's 5 carbons. 1, 2, 3, 4, 5. We know that after the 2nd carbon there should be triple bonds, so I'm going to take my 2nd carbon as that one. Okay, which means the rest take single bonds. And then also we know on the 4th one, okay, that will be this one over here, there's a methyl group. Okay, don't forget to fill in your hydrogens where they are needed. Okay, then looking at 2.3 says look at compound B. Okay, so B, we're dealing with an alcohol. So it asks you 2.3.1, write down the meaning of primary alcohol. Okay, so I'm just going to give a rough overlay of what the difference between the three are. Primary alcohol is you have your OH bonded to a carbon that's bonded to just another carbon. Okay, so the R represents the chain continuing to the left. Okay, that's primary. Secondary is the OH is bonded to a carbon that sits between 2 other carbons. Okay, so in the middle of a chain. And your tertiary alcohols is your OH is attached to a carbon that's attached to 3 other carbons. Okay, so in the memo below you'll be able to find the definition required for a primary alcohol, but this is the basic gist of it. Okay, then looking at the next questions. Okay, it says compound B reacts with another organic compound X to form a compound C. Okay, so we're dealing with B and C over there. Okay, so we know that B is an alcohol, and you should recognize that C is an ester. Okay, so 3.2.2.3.2 says the type of reaction that's taking place. Okay, so we're forming C over here. Okay, and the only way we can form C is through a process called esterification. Okay. Okay, now with esterification, you've got to remember that it's an alcohol plus a carboxylic acid. Okay. Okay, and that produces an ester plus water. Okay, now in order to get this right, you have to add in the water in order to balance the equation. Okay, so looking on the left here, we have 3 carbons, 8 hydrogens, and 1 oxygen. Whereas on the right, we have 7 carbons, we have 16 hydrogens, and we have 3 oxygens. So compound X, okay, is going to need an additional 4 carbons, 8 hydrogens, and 2 oxygens. Okay, and that is the formula for carboxylic acid. Okay, so now that we have the formula, if you want, you can draw it out. Okay, your carboxylic acid is indicated that we have a double bond oxygen, okay, and an OH attached over here to the side. Okay, and then we have hydrogens everywhere else. So looking at this, now looking at the Iupac name for it, since that's what the last question is asking, find the Iupac name of compound X. Okay, our longest chain is 4, containing our functional group. Okay, we know that it's carboxylic acid, so we can then name this 4 is but. Okay, and then the suffix for carboxylic acid is enoic acid. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, please leave a thumbs up. If you have any questions regarding any of the content, please leave them in the comment section down below. If you're finding these videos helpful, please consider subscribing to the channel, and thanks for watching.